Good morning. Okay, so today kita buat exercise 4 ni sebab this is our number of exercise semua kan yang kita dah buat. So kita masuk this one exercise 4. A simply supported beam in figure below support uniformly characteristic dead and imposed load of 5 kN per meter each, as well as characteristic imposed load of 30 kN. When dia bagi juga imposed load lagi satu ada point load. Assuming beam is fully laterally restrained and there is no nominal torsional restraint at support, checks section 356.171.67 UB to satisfy bending and shear consideration. So the difference between this exercise number 4 and example 1 yesterday, this one dia bagi you section and dia minta you check whether this section is suitable or not to be used for this kind of design. Maksudnya macam loading macam ni, you letak 10 meter load beam, size macam ni, is it okay whether it can support the design or not? So we have to check. To check it first, as usual, what we need to do, cara macam biasalah, kita kena kira loading yang 1.4 GK. Macam mana pun we will start with loading. So loading, we have the formula of ultimate load equal to 1.4 GK plus 1.6 QK. And 1.4, so right now we have 1 UDL, dead load which is 5 kilonewton per meter ni. So we have this 5 kilonewton per meter as a dead load for UDL. And for UDL pun kita ada satu lagi which is imposed load, sebab dalam yang I buat first ni for UDL dulu 5 kilonewton per meter juga. So I separatekan between UDL dengan point load lah. Okay, so kalau you buat macam ni lah. And this one kita kena darab dengan 10 meter because of the length of the beam. Okay, sebab kita nak dalam unit kilonewton. Last sekali. So because of this is per 1 meter, so kita nak for 1 meter kita darab. So kita nak for 10 meter, so kita darabkan lah. And also we have another point load which is imposed load 1.6, 30 kilonewton ni imposed load, but this one is already in kilonewton sebab dia point load So terus je darab dengan 30 kilonewton, tak perlu darab length sebab dia dah memang point load, dah dalam kilonewton. Okay, bukan UDL lagi, kita calculate dulu yang inilah. So dan macam example number 1 yang saya ajar sebelum ni, so saya akan kira separately saya tak kira sekaligus lah. Kilonewton per meter darab 10 meter, okay, and plus with 48 kilonewton. So this is the ultimate load. We will calculate the design moment and shear force. So design the beam itself, dia ada load macam ni lah, which is bila kita kira-kira semua load ni adalah 198 kilonewton kan. Loading yang kita kira kat atas ni, ultimate load ni, this is the total of 198 kilonewton ni, which means that the RA and RB going to be symmetry maksudnya sebab dia punya bunyi symmetry. Therefore balance lah. Of course reaction ni must be equilibrium with the loading yang applied on top of the beam lah. Applied mesti equal because of the equilibrium yang kita belajar sebelum ni. Kita tak payahlah kira all the like RA equal to blah 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 plus apa-apa yang you buat reaction. So you nak kira reaction sebelum ni, no need to do that. So kita just simply can write RA equal to RB equal to W divided by 2 equal to 100 98 kilonewton divided by 2. And we going to get 99 kilonewton. Which means this is actually kita punya maximum shear force, FV. Terus tulislah 99 kilonewton. Maximum shear force kita. We calculate the moment. So because of we have one point load, so kita masukkan formula point load yang actually at the midspan of the beam, which means that this is going to be the formula so that we don't need to draw the bending moment diagram and shear force diagram. Kalau you pakai cara susah, then kita kenalah lukis SFD and BMD tu. Ni shortcut because of dia kat midspan and also the UDL along the beam. And then W here, we just pick up the value from here, 48 kilonewton. Just pick up that value because that is the point load yang dah sekali dengan vector of safety. Plus with and W here, so I ambil ini semua. Sebab I tak darat lagi dengan 10 meter, so that's why kita masih boleh maintain WL square dekat sini. Kalau you dah darat 10 meter, kena pakai WL saja. Okay, if not, kita terdarab length 2 kali. Terlebih lah, maksudnya terlebih. So 15 kilonewton per meter, darab 10 meter, power of 2, divide by 8. Jocelyn 307.5. Alright. So here we actually dah dapat lah the value of moment. So next step is we going to do some beam classification. So kita nak classify kan beam ni jenis apa. Okay. Kita tak payahlah nak assume PY 275 whatsoever lagi. Okay, sebab kita dah ada dia punya section. So we need to refer to this table. Here we have this UB section. Dia punya table. 3561767. Highlight terus semua. Jadi first kita tengok dia punya T. T is actually 15.7. Okay, capital T. T is equal to 15.7 mm, which is actually less than 16 mm, which means that PY is 27. Okay, mana I dapat this 16 mm? Refresh balik, tengok balik this table nampak kalau dia less than 16 or equal to 16, PY 275. Kalau 17 up until 40, it become 265. If 41 up until 63, dia akan jadi 255, and 64 up until 100, dia akan jadi 245. But for our section here, T is actually less than 16 because it is 15 point, apa tadi? 7. What we need to do first is kita nak check dia punya size. Walaupun dia dah bagi table, sebab sebelum ni you kira size tu because you nak cari section. Tapi sekarang section dah bagi. But section yang dia dah bagi tu betul ke plastik? Modulus dia okay. Okay. Jadi kita kena check juga. So moment divide with PY. Here we can just look at value moment tadi 307.5 darab 10 kuasa 6 Newton millimeter, and we simply divide it with the PY 27. Steel strength. Zulhelmi. Betul. Thank you. 1181818. 818. Okay, betul. Ini dalam millimeter cube pangkal Newton, millimeter divide lagi dengan millimeter square. Dia akan jadi darab bila you bagi 2 kali jadi darab. Jadi millimeter cube, and what we need to do is we need to convert it into centimeter cube, which means we must bahagi dengan 1000 sebab 1 mm equal to 10 mm. Kalau kita tekan itu dia jadi 10 kuasa 3. 1, 2, 3. So kat sini I dapat 1118.181. 1118.182. And then apa yang kita buat, kita pergi check balik dekat section kita tu. Okay, we need to refer to the UB section table again. Look at our section 118.182. Now our SX is, salah, nanti dulu kita tengok dulu ni. Okay, SX tu plastic modulus. Kita kena make sure that value ni okay. 1210. Okay, kat sini adalah 1210 SX given dalam kita punya yang ikut size kita tadi from UB section. UB section table. SX is centimeter cube. Okay. So when you dapat UB section SX daripada table ni adalah 1210, maksudnya apa? Bila you compare dengan SX yang you kira due to the moment, okay, due to the moment, and SX yang you provide mesti lebih kan? Kalau tak cukup. Okay, so kita kena provide lebih daripada loading tu, daripada moment tu yang come from the load So which means it is bigger than this 118.182. Okay. So which means it is okay. Because sebelum ni kita cari SX sebab kita nak cari section. But sekarang kita dah ada section. But we just nak check whether section tu SX dia mesti lebih. Macam itulah daripada plastic modulus yang kita kira yang daripada loading bila kita provide mesti kita provide lebih kan, kita tak boleh provide less, we must provide something yang bigger classification classification. PY ni dah tak payah check lagi, PY kita memang 275, so kalau you nak tulis pun ikut suka hati you lah. Ya, tapi I dah tak tulis lah. Sebab we can simply terus tulis cari constant. Sebab we already know that PY kita 275. Sebab kita dah kira kat atas Square root. So 275 divide by 275. Simple square root. Then you will get 1. Okay, bila kita dapat satu, B over T, kita akan cari B over T and also D over T because one for flange and one for web. Sebab kita punya section ni ada subsection lah, macam ni bagikan flange and web ni different. Because dia punya size tak sama kan, flange dengan web adalah 2 different sizing. So kita kena check for both. So kita check dulu dekat our UB section table again to check this B over T and D over T. So B over T 5.52 and D over T is 34.8. 5.52 and 34.3. So ini kita nak compare dengan apa? So lepas kita dapat benda ni, the value of B over T and D over T, we need to compare with some values. So value ni mana kita nak dapat, where we can check it? We can check it from this table. Sorry because of here there's so many table that I kena drag you ke sana ke sini lah. Here, okay, one is B over T here and D over T here. And you see this a plastic compact and semi-compact. So we need to know whether this plastic compact atau semi-compact ataupun slender. Ujung sekali dekat sini ada slender lah. Tapi dia tak ada bagi any ratios, but we can just read the whatever here dia tulis Apa yang exceed this limit, maksudnya atas daripada semi-compact is going to be slender. Okay, but so kita tengok kita punya our B over T 5.52 and D over T is 34.3. Okay, so we see it is actually less than 9 constant sebab constant is 1. So it is plastic for B over T, and for D over T 34.3 ni is less than 80 constant so it is plastic lah. Both of the section adalah plastik. So, sebenarnya I tulis macam ni lah. So sebenarnya ditolak ni 9 lah. 9 darab 1. So this one plastic. This one also plastic. Mungkin kita boleh tulis balik our section. Section kita tadi I tak ingat dah. 3561767. Section kita ni adalah plastik. So after the classification then kita akan check on the shear strength. Shear strength apa? Shear strength of the section ni lah, whether the section can resist the shear stress shear force daripada loading ya. Okay, kita check shear strength. So D over T, first thing kita tengok this one dulu is refer je, tengok je kat atas ni you dah extract from the table, so we can just simply use the value 34.3. This value must be less than 70 constant. 70 constant ni I rasa dalam notes I ada bagi kat bawah, dia ada like notes from BS I ambil dari BS, jadi tulis lah for roll section steel beam ataupun column dia mesti check dengan 70 constant lah to make sure that the shear buckling tak perlu di consider. And then kita just kira for PV, so we know the formula for shear strength ni lah, shear capacity ataupun shear capacity ya. Maksudnya bila you dengar perkataan capacity, maksudnya capacity of the beam, how much the beam, how much force the beam can carry, shear force can resist, whether it can resist loading you atau tak, macam tu lah. Okay, but this is the ikut you punya beam punya section section you punya, dia masing-masing punya section dia ada capacity masing-masing lah, so that's why kita kira 0.6 darab PY and A here we know that kita just belajar up until roll I section, so PY ni, sorry, A ni memang fix jadi TD lah formula dia TD. Okay, sebab A ni TD 0.6 times 275 and we just darab dengan T and D. T and D, okay, this is shear capacity, beam ikut beam section, so apa-apa kita kena refer pada table. So mana value T 9.1 and then the value of D is 364. 9.1 mm darab 364 mm. Atika 546. Okay, betul? Thank you. 546. Okay. Soal tu, 54,000. Salah. 546,546. Okay. So here it is in Newton. Okay. Cancel this one. Newton. Jadi kita, what we need to do next is kita tukar dia kepada kilonewton. 546.546 kilo Newton bagi 1000. So kita akan compare dengan FV. Okay, so FV kita ada calculate daripada, ada kat atas lah FV ni, maksudnya shear force dari loading shear force yang from the load. Shear force from the load is actually 99. Maximum shear force you lah. Okay. I tak lukis SFD BMD. Kalau you lukis SFD BMD, you cuba try lah. You memang akan dapat FV ni 99 and maximum shear force 99. Maximum bending moment you memang 307.5. Okay, kalau you try lah. 99 kilonewton. Compare, dan kita compare the value of FV and PV. So FV you memang kecil je, which is memang less than PV. Okay. What does it mean? It is low shear load lah. Next, we need to look at the bending moment. Okay, so kita tengok, kita calculate MC dulu, which is the moment capacity. Tadi shear capacity, sekarang moment capacity. Kita nak tengok on the parts of moment lah. Formula is PYSX, this one for plastic section. Sebab section kita adalah plastik, so formula kita adalah PYS. X lah. X semua mesti arah X. Sebab beam kita horizontal member. Okay, bila horizontal member, beam, okay, why? Sebab beam memang, kalau I beam ke, L beam ke, T beam ke, semua you akan letak dia macam ni. Ni maksudnya dia akan tegak macam ni lah. Okay. Tegak. Kita tak ada letak dia jadi macam ni. Kita tak letak dia sengit. Kalau dia sengit macam ni, dia terbaring, as in dia okay, dia tak tegak macam ni. Okay. Baru ini kita kira for Y. Okay, tapi sebab beam ni tegak, jadi macam ni dia adalah X. Baringkan dia like this, okay, it will actually reduce the capacity beam ni. Okay, dia lagi kuat berdiri tegak. Okay, sebab apa? Kalau you kira ISX pun, you akan dapat ISX this one lagi rendah daripada ISX ni. Okay, kalau you kira ISX lah. I believe that you masih ingat part 1 kita kira ISX. 275 Newton over mm square. And kita akan darab dengan SX. SX ni adalah plastic modulus. Okay. Plastic modulus, okay, you ada choice whether you want to refer back to the table or you can just simply use whatever yang you dah ambil kat atas ni. I malas refer table. Okay, SX you inilah. 1,2,1,0. Kita buat kita cari daripada table. 1,2,1,0. 1,2,1,0. Okay, so this one is in centimeter cube. So kita kena convert it into millimeter cube darab 1,000 lah. Okay. So dia dah jadi 1,200,000 bla 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 bla. And then simply darabkan. I dapat 3,327,5. So millimeter hilang kat sini, so tinggal 1 lah. Kat sini, so Newton mm. So kita tukar dia into kilonewton meter, so it become 332.75 kilonewton meter. bahagi 1000 bahagi 1000 Newton tukar kilonewton bagi 1000, millimeter tukar meter bagi 1000. We also need to check whether this MC is less than 1.2 PYZ. Memang kita kena check lah. Ini apa? This is not, tak ada nama. Ini memang apa yang ditulis dalam BS lah. Kita kena check for this. How we do this? So kita masukkan saja 1.2 PY275 and value of Z here is elastic modulus. Elastic modulus ni kita tak ada lagi kira anything related to it. So we don't have the value. We need to check with the table. Nampak kat atas ni elastic modulus anything ambil dekat X. 1070. So 1070. But this one is in centimeter cube. Dalam table tu kalau tengok kat atas dia ada units. Ditulis centimeter cube So bila centimeter cube kita kena tukar dia jadi millimeter cube darab 1000. Scholastica 35 31 12 3 4 5. Okay, betul. Okay, thank you. 35 31 berapa banyak kosong tu. So 353 juta 100,000 is equal to 353.1 kilonewton meter. Ini sama juga jadi satu hilang. Newton mm. Tinggal 353.1. Kita check lah. MC must be less than this 1.2 PYZ, which is betul. Memang it is less. Which means this is okay. Next baru kita akan check this MC dengan loading kita, which means moment that come from the loading. But first kita kena tulis dululah berapa moment yang due to impose load. You can just tulis M saja kat sini. I don't mind. Tak perlu nak tulis ayat panjang because ayat saya tulis dalam notes tu just for the sake of untuk you faham. 307.5. Okay, ini adalah value moment without self weight of beam. 307.5 kilonewton meter. But this one tak masuk self weight of the beam. So kita kena kira self weight of the beam using the formula MSW ni lah moment WL square over 8. Because of kita kira self weight ni kita pakai WL square over 8 because of this is UDL So moment yang produced by self weight tu UDL lah sebab awak punya beam kan panjang macam ni. Ada bentuk I lah like this. Ada panjang kan. So panjang sepanjang 10 meter tu loading dia sama. Rupa dia sama. So it is UDL. Kita boleh masukkan lah. We know also that self weight tu adalah dead load. So dead load macam mana bila ada dead load, kita kena letak this factor of safety which is 1.4 and then kita kena darabkan dengan dia punya mass. Okay, sebab sekarang ni kita tak ada in Newton kan, berapa berat mu berapa sebenarnya. Sebab kita just ada this one sahaja, value ini. Okay, value ini is actually adalah 67 kilogram per meter. So 1 meter beam berat dia 67 kilogram. Ini sebenarnya maksud di 67. But value ni bukan dalam Newton. So kita kena tukar dia untuk jadi Newton lah. Okay. Itu adalah mass. Kita nak weight 67. So 67 kilogram. When we want to make it in Newton, so into times the gravity acceleration. Okay, kita times with the gravity acceleration and divide with 1000 sebab kita nak tukar dia jadi kilonewton. 6 kilogram darab 98 dia jadi newton. Bagi 1000 dia akan jadi kilonewton. So we are done. Ini semua adalah W. All of this. This is W. And then kita kena darab dengan length which is 10 meter length of the beam. Kenapa I punya dah waktu power length? Power of 2 and we divide with dengan 8. Wan Naim 9.202. Dapat 11.502. Orang lain dapat berapa? Okay, sebenarnya 11.502 you ada salah tekan kot. Cek balik So this is moment, sebab kat sini dia dah jadi, you dah kilogram, dah darab dengan 9.81, dia dah jadi Newton, you dah bagi 1000, dia dah jadi kilonewton. So kilonewton, so maksudnya yang ni semua, dia dah jadi kilonewton. And then you ada pula this meter, darab dengan meter per meter darab meter kuasa 2. So akan jadi meter lah juga. So 11.502 ini baru MSW. So kita kira MT which is total moment. So you ambil je M plus MSW. 307.5 plus 11.502. And we will get 319.002. Kita comparekan with MC 332.75. Yang ni awak punya MC ni. Comparekan dengan our MT, total moment. Maksudnya moment yang come from the beam, the self weight of the beam, and also the loading. Mestilah moment tu less than the moment capacity yang beam tu can support. So kita kena make sure that MT is less than MC. And value dia actually less because this is 332.75 and this one is 319.002. So MT is less than MC. Apa maksudnya? Proposed section is suitable lah. Okay, we are done.
Soalan ni berapa markah Miss?
Markah dia berapa? Markah dia around 20, 12, 15. Markah dia tak banyak like 12 to 15 marks. So if no question, I will end the class here. Thank you everyone. Yeah, alright.
Thank you Miss.
Okay, have a nice day. Bye.